Hi, I'm Stu from HiveMind Automation and welcome back to the Hive. In this video, we're going to be taking a look at adding NVMe storage to the Home Assistant Yellow and transferring the data to that NVMe storage. Now, this should hopefully be a pretty quick video, but these concepts will work even if you're not using NVMe storage and even if you're not using a Home Assistant Yellow. But we'll get into that a little bit later on in the video. So while I roll the intro, why don't you take a moment to subscribe? And if you hit the bell icon, you'll get a notification when I release a new video each week. While you're at it, if you like what I do here and you want to support the channel, there's affiliate links to smart home gadgets that you can buy for your very own smart home and support the channel at the same time without costing you any extra. Or you can support the channel directly through my Buy Me a Coffee link. Of course, those affiliate links and my Buy Me a Coffee link can all be found on my website, hivemindautomation.com.au. With all of that out of the way, let's get started. So if you've been watching the channel for a while, you'll know that around 2 months ago, the SD card in my production Home Assistant Raspberry Pi 4 failed. At that time, I switched over to using my Home Assistant Yellow, and the Home Assistant Yellow has a Raspberry Pi Compute Module 4 in it that includes eMMC storage on board. And I will say that everything's been humming along mostly okay since then, right up until a couple of weeks ago. You see, because I make these videos, I like to keep my Home Assistant installation as up to date as I possibly can. So at the start of October, I successfully updated to 2023.10.0 and then subsequently to 2023.10.1. Now, unfortunately, there's been a handful of releases since then, and I've had trouble installing them because the eMMC storage on my Raspberry Pi Compute module is very close to full. To demonstrate, over here on the right, I have my Home Assistant Yellow. This is my HiveMind production instance here. And if I go into settings, you see that we have the Home Assistant core update for 2023.11.0. And if I click on that, and we've got create backup before updating. If I click install, we get failed to call service update install. Basically what it was saying there is that there's not enough space on the internal eMMC storage in order to install that update. Now, if you've ever seen an error message saying that you can't upgrade because there's not enough free space, I will tell you that any upgrade at that point is going to be a scary prospect. And it's worth remembering to always take your backups and make sure that they're saved somewhere safe. As I mentioned in the episode where we were initially setting up this compute module and adding in some of the features that I had lost, I added in a new feature where I save my backups now to network storage so that those backups are then at least not on the Compute Module 4 internal storage there. At any rate, it's all become very clear to me that the eMMC storage isn't a viable long-term solution, at least in my setup. So I jumped onto Amazon and I picked up this 500 gigabyte Samsung 970 EVO Plus NVMe SSD for 75 Australian dollars. Now, of course, I made sure to do some research beforehand to make sure that this SSD would work in Home Assistant Yellow. And from my research on the Home Assistant page, this is one of the ones that has been set up successfully. Now, a 500 gig SSD is absolutely overkill for Home Assistant, but at the time that I ordered it, a 250 gig SSD was $55. So the value proposition was better for the 500. Now, I should mention that you can actually do the same thing here with Home Assistant running on a regular Raspberry Pi. You don't need the Home Assistant Yellow to transfer to another drive. The only thing here is though that a normal Raspberry Pi would need to have the external drive connected via the USB ports, and I wouldn't want to do that on a Raspberry Pi 3 because the Raspberry Pi 3 only has USB 2.0 ports, whereas the Raspberry Pi 4 does have USB 3.0 ports. Now I happen to have a USB 3.0 to SATA adapter here and a 2.5-inch SSD, and I will demonstrate doing the same thing on my Raspberry Pi 4 demo instance a little bit later on. So obviously first things first, we need to get the NVMe storage installed into the Home Assistant Yellow. Before we do that though, it is vitally important that we take a full backup of our Home Assistant configuration just in case. Now, while we are transferring this data to the NVMe storage, there is still a possibility that something could go wrong and we may lose our config again. So back over here on my HiveMind production instance on the right hand side here, I'm going into settings, and then I'm going into system, and I'm going into backups, and we've got a full backup that I took yesterday, and that went to my HAS backups location. I'm going to create a backup, and it's a full backup, and I'm just going to leave the backup name alone, and I'll tap create there. While that's taking that backup, I'm going to mount my HAS backups folder over here on my laptop, and I will bring that up on screen shortly. I've got my HAS backups folder open here, and you can see that we have this this folder that's been created. This is the temp folder while we're creating that backup, and this is on my server here. Now, out of an abundance of caution, I have got myself an ESD mat here, and I'm also grounding myself using a wrist strap so that I can be certain that I'm not going to have any issues with electrostatic discharge for this Samsung SSD or for my Home Assistant Yellow here. Now, it's also crucially important that you have a feline helper while you are installing your NVMe storage, and the cat should also be grounded using the ESD mat. So I'm just going to disconnect the PoE cable here and also unplug the Home Assistant Sky Connect, disregard that presence of that for now, and open up the case of the Home Assistant Yellow here, and I'll take the bottom case away as well. And we've got a little mounting screw here for the SSD. I'm just going to unscrew that. It's held on the bottom with a tiny Phillips head screw. I'm just going to remove that mount and that screw, and hopefully the cat doesn't bat them away there. So with those removed, I now need to open my SSD here and pull it out of the packaging here, and we've got our 970 Evo Plus. So with my wrist strap on, I can safely remove this from the packaging and put the packaging aside and install the SSD into the NVMe slot here. So with the NVMe slot installed, I'm going to just grabbing this little mount piece here. You can kind of see that it's machined with this notch, and I'm just sliding that notch over the end of the SSD there, and then I'm going to push that down so that it lines up into the hole that corresponds at the bottom. Take the screw that we took out from the bottom, and we're just going to screw that in, and there we go. So that's in there, and it's mounted there properly, and it's held tightly in place. Now I'll grab the casing again and lid back on. Install the 4 enclosure screws / feet back here as well. So now with everything buttoned up, I'm going to plug in the Ethernet cable, which includes the PoE, and we're just going to wait for that to boot up, and it will take a moment or two to boot. So Home Assistant is starting up now, so we just need to wait for that to finish. So the good news is that it is starting back up, even though we've modified the hardware. So it looks like Home Assistant has finished starting up. So now I can go over to settings here, and if I go into system and into storage. So in storage, you see we've got 93% used, or 92.6, but we've got 10% of our eMMC life is used. But if I click move data disk now, it says we're currently using, that's the eMMC address as the data disk. Moving the data disk will reboot your device, and it's estimated to take 10 minutes. Your Home Assistant installation will not be accessible during this period, and do not disconnect the power during the move. In the drop-down menu, we can select our Samsung SSD 970 EVO Plus, and it shows us the size and the serial number. In the drop-down, select the Samsung SSD, and we're going to click move. Now it says this is going to reboot and move the disk, so we need to have some patience. This may take up to 10 minutes. When we look at the USB disk on our demo instance, I might look at doing that with the command line utility instead. And so now we just play the waiting game.
8.5 minutes later.
All right, so I'm not entirely sure how long it's been, but it looks like Home Assistant just finished starting up. So we will back out to our overview, and I might just zoom out one more spot there. So we do have Home Assistant up and running. And if I go to settings now, we see we've got some more options. But if I go back down to system, and I'll go to storage, we now have only 3% used and 427 gigabytes free. So we are doing an awful lot better than we were with the eMMC storage internally. So what we can do now is show all of our updates and get our updates installed. So I'm going to start off with the core update, get that installed, and then we will do a little bit of testing. All right, so I've got everything updated now. I don't have any more pending updates on my settings page here, which is fantastic. Like, it's been like that for about a month. I'm so glad to have those updates applied. There seemed to be a lot more available once I moved the data disk to the NVMe SSD as well. So that's actually kind of interesting that it seems like Home Assistant wasn't showing me updates that I couldn't install because I didn't have enough space except for the core update. So that's kind of interesting to note there. So just over on my B camera here, I've got, this is a USB 3.0 to a SATA disk connector and a 2.5 inch SSD. Now, what I'm going to do, now that we've got this sorted out on my production instance, I'm going to go and install this SSD into my demo instance here. We've got over on the left of my laptop screen, and we're going to take a look at transferring the data using the terminal method. Okay, so I will say that obviously installing a USB disk into a Raspberry Pi 4, the USB 3.0 port, not the USB 2.0 port. That is a very important distinction. That's obviously a much quicker process because we don't need to power down the Raspberry Pi to install it. If I now click on Move Data Disk over here on my demo instance, it seems like it's not seeing that disk. What I'm going to do is I'm going to restart my demo instance here. and I'm going to fully reboot the system. I did say earlier that using the USB method does mean that you don't have to reboot, but it turns out you do. So just bear that one in mind. So after restarting my demo instance and fully rebooting, I'll go to Settings, I'll go to System, and I'll go to Storage. And I'll click on Move Data Disk, and now we actually get the option to move the data disk, and it tells us what we're using. That's the SD card. Instead of going through this same method, I'm going to go to the terminal, and I'm going to make this nice and big so that you can see exactly what I'm doing here. I'm going to go HAOS info, and I'm going to grep data underscore disk, and we see we've got the SD card address there. I'm going to go HAOS data disk list, and we've got the SanDisk SSD at devpath dev SDA. So now I'm going to go HAOS data disk move /dev /SDA. I'm going to run that, and this is doing exactly the same thing as the UI. It's rebooting the Raspberry Pi and transferring the data from the SD card over to the SSD that we've installed. I'll just zoom that out a couple of steps so that we now have, we can see the UI, and we just really have to wait for this to complete the reboot because we've got connection lost reconnecting here. So that's adding SSD storage to the Home Assistant Yellow or a Raspberry Pi 4 and transferring your Home Assistant across to that SSD. The process is relatively straightforward, and there's a number of benefits doing this as well. The first and most obvious one to talk about is the fact that the large capacity SSDs are pretty cheap compared to, in the case of a Raspberry Pi 4, a large capacity SD card, and certainly a lot easier to get your hands on in higher capacities than something like the Pi Compute Module 4, which are still in very short supply. These NVMe SSDs and the 2.5-inch SSDs are engineered to be more durable and more reliable than a regular SD card, with many of them having significantly longer warranties than SD cards. And even if there are failures on an SSD, they tend to be far better at handling those errors than SD cards due to their use in PCs and laptops, where an SD card, generally when that fails, it fails catastrophically at the first point, as opposed to maybe slowly degrading performance before a catastrophic failure. And you do tend to get some warnings prior to that catastrophic failure, even when you're just getting the performance degradation. Lastly, any SSD, whether it's NVMe or a 2.5-inch form factor, is going to be significantly faster than an SD card or even eMMC for read and write access. eMMC is still faster than SD, but even through the USB 3.0 port, an SSD is going to be way faster than an SD card or an eMMC storage option. That faster performance is obviously going to improve the performance of your Home Assistant server. Now, when I say performance, I'm not just talking about how quickly your lights turn on and off or how soon after an event occurs that you receive your notification, because you're honestly unlikely to notice any significant difference there. Where I do expect that you'll see a significant improvement is how quickly the system is back up and running following a reboot, and especially after that reboot, how quickly it will be able to load all of your integrations and be in a state of full readiness after that reboot. I timed a full system reboot of my Home Assistant Yellow with the eMMC before this upgrade, and from what I can see, it took around 5.5 minutes. I'll put the actual timer on screen here, and also the recording of that time. And that's from the time that I clicked the last reboot button to then getting the alert in the bottom left corner of Home Assistant that the reboot has finished starting up. Now that we've got the NVMe drive set up in our Home Assistant Yellow here, I'm going to test that out again and see if my theory holds true that the reboot is quicker. So over here on my production instance on the right hand side here, I'm going to go to settings, and then in the three dot stack, restart Home Assistant. I'm going to open up advanced options and I'm going to reboot the system. This is exactly the same as what we did in the initial test, and I'm then going to click on reboot and reboot the system there. So I'm just hoping that this theory that it should restart faster does hold true. It seems like it's now starting up the supervisor. Not everything will be available until it's finished. I'm just waiting to see. So Home Assistant has started. Now, I do feel like that maybe took roughly the same amount of time. So it's hard to gauge without actually playing back the footage and timing it out properly. But we will take a look at that in post, and I'll put the numbers up side by side so that we can see how much faster, hopefully, the NVMe drive is at booting into Home Assistant. But at the very minimum, the primary benefit that we've got here is that we've used so much less of the space that's available to us. So we have space on our drive now. We could store some additional media, so music or video files on this SSD and play them back directly from Home Assistant to various media players around the house. And there's many other things that we can do here. What we should find throughout the UI is that many of the functions within Home Assistant should hopefully be a little bit more reliable and a little bit faster to load. Now, to some degree, we may not notice much difference when working through the UI at all, because a lot of this information is going to be loaded into RAM on the system as opposed to running direct from the disk. So certain things may not be that much faster when you actually look at it on the surface, but eventually things like this Studio Code server loading, the add-on, that stuff does appear to load from disk, so it will end up being a little bit zippier. But as I mentioned, media, we have so much more space for media now that we can use, and it does seem to be at least a little bit faster. We can also see very clearly that it's going to be a fair bit more reliable for us to be able to update Home Assistant in the future. The key places where we're going to get improvements are things like the logbook and the history pages. These logbook and history pages are reading from the Home Assistant database. If I go into terminal and go lslaH here to take a look, and if I go to cd config and same thing, LAH, and we see we've got these Home Assistant databases here. So these databases can actually get fairly big in size. This 583 megabyte of Home Assistant v2 database here. And that database is what feeds the logbook here. So you see we've got this logbook loads really quite quickly now. And even if we were to choose a device here, say this device tracker for Alfresco, we can actually get this information really, really quickly when we add this. This is loading so much faster than what we would see on eMMC storage. So that's where we're really going to see this these improvements, is the history and the logbook data especially. So yeah, you can see how zippy that is. On eMMC storage, that would take probably a second or two to load. And certainly on an SD card, you'd probably find that that takes up to a minute to load that information. So hopefully that illustrates how much of an improvement you can expect to gain by adding NVMe storage to your Home Assistant Yellow, or SSD storage to your Raspberry Pi 4 if you are using either of those setups for your Home Assistant. It's definitely worth considering making this change if you are set up in one of these configurations. And as I say, we now have a lot more space available to us to install additional add-ons into the system to make sure that we're up to date. Our database can grow in size and not really run into any kind of constraints there. And also we can put local media onto our Home Assistant setup and stream that media to our media player devices as well. That is all we have for this video, and I do hope that it helped you in your home automation journey. Be sure to drop a comment down below with home automation ideas that you'd like to see me cover in a future video. And don't forget to follow HiveMind Automation on Instagram and Facebook. If you like this video, drop a thumbs up down below to give it a like. And also, if you're not already subscribed, now's a great time to look at changing that. If you do subscribe, if you hit the notification button at the same time, you'll also then get notifications whenever I release new videos, which is normally each week. Lastly, if you enjoy what I do here and you want to support the channel, there is a Buy Me a Coffee link in the video description below. Any contribution you make through Buy Me a Coffee does get put towards making more and hopefully better content for you to enjoy. Don't forget to also check out my website, hivemindautomation.com.au. Thank you so much for watching. I'm Stu from HiveMind Automation, and I'm looking forward to seeing you next time. Bye for now.